Okay, so you look at the three cases here, and the three cases are that this thing is imaginary, which is going to give you the, through the Euler identity, the oscillatory solutions. Zero, which just leaves you with the, it's still there, the negative gamma over 2m, e to the negative gamma over 2m times t. Okay? Or greater than 0, which is just going to give you a combination of two exponentials. Okay, so let's see how that works out. So I ask you to work this out, you know, because what this is equivalent in this. Okay, and this is what occurs for increasing gamma. A little bit of gamma, it's imaginary. Just the right amount of gamma, right amount of drag, it's 0, and for a lot of drag, it's real, and things behave the way we said. So, for a little bit of gamma, you have this, and that occurs, and you solve this inequality very easily, put the k over m over there, right? And gamma is going to be less than 2m, well, actually, we'll say 2 square root of km, right? Okay.
Is that always true? Because don't you have to be careful when you square or square root an inequality? Like,
well, I mean, your inequality, you're going to have 4km, right? You put this over here and multiply by 4m squared, you're going to get a 4km.
yeah.
And the square root of 4km is 2 square root of km.
Yeah. But wouldn't the direction of the inequality depend on the value of km?
No, because km is always positive.
Wouldn't it depend on whether it was between 0 and 1 or between 1 and something greater?
Nah. Think about it. Gamma squared has to be less than some positive quantity. So gamma has to be less than the positive square root of that quantity. Well, it could be between the negative square root and the positive square root of the quantity in general. But there's no such thing as a negative value of the product of two positive constants, right? So there's no negative. You know, they make no sense for gamma to be negative. Gamma can't be a negative.
Okay.
Okay, you don't have negative drag, except in cosmology where you have dark matter tending to expand things, and maybe in diamagnetism where you impose a magnetic field on many materials and they kind of get this repulsive magnetism, this negative magnetism. It's in your book, you can read it. Won't have a lot of time to discuss it. We'll talk about it a little bit. Okay? Okay, so here, well, you know, this is pretty easy. I say it's pretty easy. Let's hope I've done the algebra right. This is all screwed up. I'm not going to take the time to check the units of this, but what does gamma have to be in units of? It has to be force per unit of velocity, right? Because you're multiplying it by velocity to get force. It's got to be force per unit of velocity. Okay? So is the square root of km in units of force per unit of velocity? Okay? I'm not going to do it right now. Check it out, because if it's wrong, then I did something wrong with the algebra. And learn to check things out that way yourself, just spontaneously. Never trust things without verifying and checking. Epidemic of not checking stuff throughout our whole culture. And not just in mathematics, I guess, but that's a different story. Okay.
These results would be all statistically significant. Hear that phrase? Maybe thinking
So we have just this. Okay. If you know the restoring force constant in the mass, you can figure out what the critical value of gamma is, of your drag force. Now,
use it that way. You're out there in the real world working on a job. Use the language that people can read it and what you're trying to do.
in this case, your fundamental set is e to the negative gamma over 2m, and I'm actually going to remember to put the t in here. This chalk isn't writing quite nicely. You understand that's a negative gamma over 2m there, even if it's a little smudge. Times
We rejected all. I want to hear that. They didn't say that. I want to hear that. They have rejected it.
I really want to,
That's the way you take the conclusion.
I'm just going to say times cosine of omega t, and e to negative gamma over 2m t sine of omega t, omega equal the square root of k over m minus gamma over 4m squared. Okay? That's it. If you don't have too much drag. Now gamma equal 2 square root of k over m implies your only solution, x equals e to the negative gamma over 2m times t, except in this case it's a repeated solution. Okay? So you could also have, it turns out, a t e to the negative gamma over 2m times t. Okay? And you run through the reduction of order thing.
Two-tail test, they're going to claim your status quo is it's equal to this, and the alternative to that is it's not equal to that, which means it could be higher or lower.
Okay? Now I haven't
Two-tails to say that it's something else. It's
proven the
different.
details of this, haven't run through the details. Since I'm doing this spontaneously, take this with a grain of salt.
No, here's,
Okay?
it says, does this result suggest proportional
You could plug it back into the equation and see if it works, in which case it's okay. Or you could go through the whole process. Reduction of order. You got one solution to the equation. Now you do reduction of order and find another solution. It's constant coefficient,
Moving on, let's see.
so it should work. Okay? Again, I didn't know what you're going to ask, so I didn't stop to think about this. And I don't want to take the time to think it through right now. But we've been through that process. That's where you got to know it. That's where you've got to need it, right?
P from the null is 0.46, not 1 minus 0.46.
And then
And they said that came out to be about 14.7.
I left my K off here. Okay? Implies that your fundamental set is, don't have a lot of room to write this. Maybe I've got room to, okay.
Price dash test 1 portion C.
Okay, does that make sense?
0.179. What do you think?
Can you see what I wrote? If you can, then the camera can. Okay? In other words, it's just this. And this is now real, right? So it's going to be e to this times 2. And I left my, good thing I looked there, I left the 2 off.
Here's something about that you can do on the calculator. If I take
Actually, I didn't.
9 and divide it by 12,
The 2 in the denominator, you know, it's a little different than that, but comes down to this in an obvious way. Okay? And e
they were testing two-tailed.
to the negative gamma
But in
over
reality,
2m
one-tail should they?
minus
One-tail might use the tail test.
square root of the same thing
Look at your p-hat
times,
and look at your p-naught. The sample came in.
this board can only go so far before it tips.
So is there any chance that getting a bachelor's makes it go up? Is there a possibility that getting a bachelor's made it
Okay.
go? Less than 211? See what happens. Every now
Alright.
and then when your two-tail fails.
There's your gamma squared over 4m minus k over m.
See that?
Again, right?
All the numbers are the same.
Now, it looks like this plus thing might give you a positive exponential, an increasing exponential. And you know that something, when it has a constant restoring force and a drag force, that the amplitude, or that's not going to
They said, question
spontaneously move away from equilibrium, right?
different.
Unless it does, then we have a perpetual motion machine or something, right?
Well, you know, you have the cosmological constant, but it's not going to do that. If you don't understand what I said, look up the cosmological constant, which Einstein said at first was his greatest blunder. It turns out to really be there. We don't know why.
I think that that foundation.
At least
we
they
think
don't.
it's-
I haven't told them.
We think it's there right now, right?
Huh?
Like,
Something's causing the universe to expand. Okay?
people say we just call it the cosmological constant because we don't understand it.
Yeah, well, yeah, Einstein thought he understood something. So he just kind of accidentally came up with something that was right. Wasn't an unreasonable thing to do. But then he thought he'd made a mistake, called it his biggest blunder. Okay, well, anyhow, so here we've got this. Now, let's be careful about this. Note that this exponent here, note that this thing's always negative. That's important, because otherwise this is an increasing exponential. So can you explain why this is always positive?